All right, here we go. It's 2.5, transformations of functions. I am super psyched. I hope you are super psyched. Some of this is review. Again, a lot of the stuff in this chapter is review, but definitely something we want to go over, and we'll be doing some more challenging things with it than you've ever done before. Who doesn't like a good challenge? Alrighty, so we're going to talk about all the different numbers you might see here in a function, and this will apply to really any function that we're dealing with, whether it be the square function, right? Quadratics might be the square root function, absolute value, et cetera, et cetera. Anything from those families, we can transform. We can shift left, right, up, down, stretch it, compress it. Oh my goodness, there's so many fun things we can do. We can reflect it. Oh my goodness. My goodness, this is gonna be great. Okay, so the first one, we've got let's see here, A transforms it how? Well, it's out front, it's outside. What that's going to be is it's going to be a vertical stretch or compression. Forgot the T there. Whoops. There we go. So if it's a number that's larger than 1, it's a vertical stretch. If it's less, between 0 and 1, it's a compression. Alrighty, so that B inside there, B is going to be a horizontal. And then it's going to be a stretch or compression. And we'll get more into these details in a bit, but remember, inside the parentheses there, we're thinking like opposite or the reciprocal when we're dealing with that. That's always the funky one. All right, so C is going to go left or right. Right or left. D moves it up or down. And then lastly, negative A transforms. And what we're really focused on is just the negative out in front, the opposite, right? The negative there. That is going to be a reflection over X axis, or ROXA for short, because it's always fun to have a little abbreviation, ROXA. And remember, we are mainly focusing on that negative out in front of the A. The A is still its own transformation, but when it's a negative, there's a reflection, then the A will still stretch or compress it if it's there, okay? If it's a number other than 1. Cool. So let's talk about this box over here. And as you can see, what I mentioned before, we could deal with any type of function, okay? These are just a couple examples of like our radical, our absolute values. Inside the parentheses, maybe there's squared or cubed, something out there, an exponent out there, right? When it's outside, it's just the same. And what we mean by that is this is a positive 3, we're going up 3. This is a 1/3. It is a vertical compression by 1/3. What you see is what you get. Now, when we're talking about horizontal, when it's inside, it's the opposite or the reciprocal. Okay? Hopefully the abbreviations are all right with you guys. Feel free to speak up if you're like, hey man, what's that mean? All right. Not that I can answer you in the video, but you can ask in class. All righty. So here I have x plus 2. We're thinking opposite, so we're actually moving to the left 2, which we usually associate left with their negative x values, right? But we're thinking opposite here. Now, here we have a 2 inside the parentheses. It's multiplication, so this is going to be that B value right there, horizontal stretch or compression. Since we're thinking now reciprocal, we're thinking horizontal compression by 1/2. Awesome. So we've got all the nuts and bolts here. We're ready to start applying some of these things. We're going to do maybe a little bit more with it, but man, this is fantastic so far. All right, so here we have some examples using the absolute value parent function, okay? And what I really like about this chart here is that we are also writing it in function notation. This is something that we are going to stress here in pre-calc honors. You're going to see a lot of function notation in it, and it kind of looks funky at first, but you'll get used to it, okay? So let's take a look at the vertical translation. So this is when we're going up or down. You see how we have f of x plus k. That k is outside of the function. And here's a couple examples. 3 units up, 4 units down, right? We're adding 3 on the outside or subtracting 4 on the inside. When we look at our horizontal translation, see how we have x minus h on the inside of the f of, okay? It's on the inside of the function. And an example when we're using actual numbers with an actual function would be x minus 2, we're going 2 to the right. X plus 1, we're going 1 to the left. opposite of what we see, right? That's what happens with those horizontal transformations When we're on the inside, we think opposite or reciprocal. Now, with a vertical stretch or compression, remember that multiplication is happening outside of the function. We have the a times f of x. A numerical or an example of that with the absolute value would be a 6 times the absolute value. That's a stretch by 6. And then when the 1/2, we have a 1/2 on the outside, it's a vertical compression by 1/2. Cool. All right. So far, so good, I think. Nobody's raised their hand. It's a video. I'm recording it. I can't see you. Horizontal stretch or compression. We have 1 over b times x. And I think this really gets illustrated very well when we get into trigonometry, graphing those trig functions, which you've had a little bit of exposure to in Algebra 2 Honors. So we have our 1/5 times x inside. That's a horizontal stretch by 5. And then when we have the 3x on the inside, it's a horizontal compression by 1/3. And lastly, we have our reflections. You can have a horizontal or a vertical reflection. So when it's on the outside, that is our vertical reflection. We reflect across the x-axis. Although the x-axis is our horizontal axis, when we reflect over it, you can kind of see my hand there, we are doing an up and down movement. I'm moving my hand up and down. That's why it's a vertical transformation. When we go across the y-axis, we are reflecting left and right. That's a horizontal transformation. All right. Lovely. Now, one really important thing to note, which is why we have this dude with a very interesting looking arm there. That's a weird little check mark, but whatever. You have to factor out when you're on the inside of the function and you're trying to figure out your horizontal transformations, whether that's a stretch or compression or a left-right movement. What we mean here is you see how we have 3x plus 6. I cannot have a coefficient in front of my x and be able to analyze that left-right movement. What I have to do is factor out that 3. Now I have an x plus 2. That is 2 to the left, not 6 to the left, okay? Yes, the horizontal stretch compression stays the same. This is still a compression by 1/3, but that left-right movement would be messed up if we didn't factor out that 3 first. All right, cool. Even with a negative in front of the x, we want to rearrange and pull that negative out so that we see that this is actually a right shift by 4, and we still have our reflection over the y-axis, which we would have noticed here, but we would have had our left-right movement wrong. Okay, so we got to make sure that x is just 1x, okay, when we are analyzing this for transformations. So definitely star that, circle it, highlight it, throw some glitter around it, something to make it stand out so you don't mess that up. All right, we're going to do a few practice problems here, guys. I'm not going to do every single one of these in all the examples. However, your keyed notes, which are posted online, have all of these answered. So if you are like, hey, I want to try a few more and check my work, you can absolutely do that. But I'm just going to explain a few of these to keep this video length a little bit shorter than it would be if I did all of them. All right, so let's just try the first one here. We have negative x cubed plus 3. So the first transformation I see is a reflection, and that's going to be a reflection over the x-axis since it is a vertical transformation when it's on the outside of the function. All right, so reflection over the x-axis. Roxa. And I am moving up 3. Cool. And when we are doing these transformations, we are making sure that we do the order of operations, right? PEMDAS, we're paying attention to that, working our way from the inside out of the parentheses so that because if you do some shifts before others, it'll actually be incorrect, okay? So you got to pay attention to the order. As far as our domain is concerned, this is a cubic function that has been reflected, but a cubic function, regardless of being reflected, the domain is still going to be negative infinity to infinity, and my range will also be from negative infinity to infinity. Okay. Awesome. Or all real numbers if you're using set builder notation. Let's see, what else we want to do? How about number 4 over here? And I'm going to zoom in just a little bit if I can. Cool. All righty. For this one, I have a 6 inside of the square function, which means that this is going to be a horizontal compression by a factor of 1/6, right? I got to think reciprocal in this. Little voice crack. I'm going to leave it. And then I'm going up 11. Awesome. Now, this is a quadratic, right, a square function. So this looks something like that, and it's been shifted up 11. Now, my domain is still going to be my all real numbers or negative infinity to infinity, but since I shifted this up 11, I am starting at 11 and then continuing on to infinity for that particular domain. Or we could say that y is greater than or equal to 11 if we're using set builder, right? Most of the My Math Lab asks us for interval notation. Sometimes it writes it in set builder. It's good to be savvy with both. The last one I'm going to do here is number 6, and I think you might know why. First, I want to factor out a GCF in this one. So I'm going to have the square root of, I'm going to pull out a 4, and then I'll have x minus 2. I have to do that in order to analyze my shift properly. So first thing I'm going to do is I'm going to go to the right 2, and then it's going to be a horizontal compression by 1/4. Awesome. All right. So now we want to think about our domain. Well, this is a radical function, so it looks something like that, right? That's our parent function if we were to look at it on a graph, okay? But I have shifted it to the right 2, so my domain is now going to be 2 to infinity. I do include that point 2 on a rational. And my range, I didn't move it up and down at all, so it's still going to be from 0 to infinity. Bracket, parenthesis, awesome, fantastic, America, freedom, rock and roll. All right, so with this one here, we got we're going to actually write some equations ourselves. So given the parent function and a description of the transformation, write the equation of the transformed function f of x. So again, I'm just going to do a couple of these, and then if you want to check the guided notes that are keyed, you are more than welcome to if you want to try a couple more examples if you needed them, or just head right to my math lab. All right, so let's start with the first one. Absolute value, we're going to have a vertical shift up 5 and a horizontal shift to the right 3. So if it's absolute value, if I have a horizontal shift to the right 3, that's going to be x minus 3 on the inside, and the vertical shift up plus 5 on the outside. Awesome. Fantastic. Wonderful. And then I'm going to do the last one, number 14. So we did 8, and we're going to do 14 as well. I'm just going to write it down here because this one has a lot going on. All right. I have a radical function, okay? It's a square root function. It has a horizontal stretch of 4, okay? It's translated 3 units to the left, 5 units down, and it's reflected across the x-axis, okay? So that reflection across the x-axis actually happens first. That's out in front. Now I have a horizontal stretch of 4, so that means there's a 1/4 going on, right? Okay. And then we have a translation of 3 units to the left, so x plus 3. I like to be very careful with these. And we're going 5 units down, so that's going to be on the outside. All right, so let's see if we have this all totally right. I have my reflection across the x-axis. I have the horizontal stretch by a factor of 4, so we did the reciprocal. I moved to the left 3, opposite sign, right? And then down 5. On the outside, remains the same. I think we're good. I think really we should have said this part first, okay? But you know, this is fantastic. This is fun. This is great. I love reading words and making math. All right, for this problem here, we've got to identify the domain and range of the function. We want to describe the transformation from its parent function and plot at least 3 exact smart points. And what we mean by that is points with integer coordinates. So x and y need to be integers, okay? All right, and I think that's just a nice way to graph things so you're not in between spots, whatever, right? We like having integers when we're graphing. Okay. Let's try number 15 here, and maybe one other one we'll see. For this one, we got a radical function, right? Let's see here. I'm going to graph it, and we'll talk domain and range, and we'll talk about its transformations as well. I think we could probably describe the transformations right now actually pretty easily. We have a vertical stretch by 3, and we're moving to the right 2, and I feel like that helps us graph it, and then seeing the graph also helps us with the domain and range. We could do it from here, but I think we'll do it after we do the graph. So I'm going to the right 2. Now normally I would be starting at 0, 0, but for this one we're moving to the right 2. Now as far as my integer coordinates go, I want to think, well, what's nice to square root, right? What's a perfect square root? Perfect square. So I would if I plugged in 2, I'd get 0. That's just 0. We've already used that one. So square root of 1 is something that's nice, right? Square root of 1 is 1. So how can I get 1? Well, if I plug in 3, 3 minus 2 is 1. So I'm going to do 3 minus 2 is 1. 1, the square root of 1 is 1 times 3 is 3. So I've got 3, 3 is my point. And then what's my next perfect square? I would have 4, right? So how do I get 4 inside the radical? Well, if I plugged in 6, 6 minus 2 is 4. Square root of 4 is 2. 2 times 3 is 6. So the point 6, 6 is on there. And now I have 3 points with integer coordinates. All right. Now, how about our domain and range? And I'm going to zoom back out so I have room to write. My domain, well, I start at 2 and I continue on to infinity. And my range starts at 0 for my y values and goes on to infinity. Lovely. Now, again, we could have done that just from the equation and what we know about a radical function, but I think sometimes looking at the graph also helps. All right, I think we'll do number 18 next. So for 18, we have a cube function, right? Now let's talk about our transformations again. We have a reflection over the x-axis, Roxa, and we're going up 1. Okay, so first we reflect it, and then we move it up 1. Cool? Now, for this one, it would normally start at 0, 0, but I reflect it, still 0, 0, and then I would go up 1. So I'm going to be starting here. So I have the point 0, 1, and then let's think about something else. How about we plug in the number 1? I'll do that. If I plug in 1 here, 1 cubed is 1, make it negative, add 1, I get 0. So the point 1, 0 is on there. And we might be able to realize that, okay, well, the other one would be negative 1, 2. But why don't we do that? Negative 1 cubed is negative 1 times negative 1 is positive 1 plus 1 is 2. Woo! Sometimes it helps writing those things down. But negative 1, 2 would be my other point. I have 3 integer points. We know that a cube function is going to look something like that. Woo! I was kind of shaky on that one. Sorry. Boom. Bada boom, bada bing. I like it. Excellent. Wonderful. Other than the shakiness of the hand. All right, let's talk domain and range. Well, my domain is going to be, well, it never stops going to the left. It never stops going to the right. Negative infinity to infinity. And my range is the same. It never stops going down, never stops going up. Negative infinity to infinity. All real numbers for both. Wonderful. Fantastic. That was great. All right, so for this last set of problems here, we are going to determine the equation, and we're going to figure out the domain and range, okay? We've done the square function bit, we've done the square root function, absolute value, but I feel like we haven't really touched a whole lot on our reciprocal function from our library of functions. So let's do number 20, and we'll call it a day on examples. We'll do a little bit, as you see below here, but let's go for it. So our reciprocal function is 1 over, where f of x equals 1 over x, right? And what have we done with this function? We've shifted it up, it looks like 5, because we would see a horizontal asymptote here at 5. So our function that has been transformed is 1 over x with a vertical shift of 5. That's it. That is our equation. Now for our domain, it's a little bit more cumbersome to write with interval notation, but since our book usually asks for that online, we'll do that. I'm going from negative infinity. And then what am I taking out here? I'm taking out, from this vertical asymptote, 0. And we can also tell that from looking at our function, I can't divide by 0, so I have to omit that. And then I'll pick back up, not including 0 again, and go to infinity. In my range, same kind of idea here, but it was moving from down here at the lowest, from negative infinity moving up. I'm going to skip over 5 because of my horizontal asymptote. So negative infinity to 5, not including it, and then from 5 to infinity. Fun fact about rationals, you can actually cross a horizontal asymptote. That happens sometimes, but we'll get there when we get there. That's just a little bit of a something to look forward to, I guess. But here, it's just going to approach it, get infinitely closer to it, but never actually touch 5. Never going to cross that vertical asymptote, just gets infinitely close. We're good. We got the equation. We got the domain and range. Awesome. Just if you need to write something like this down, feel free to pause this right here at the end for our, our set builder notation and equality notation. We also have our interval notation. Those are things that you've been exposed to. Our book tends to use interval notation when you're typing it in. However, we've seen some multiple choice examples where they use set builder notation. It's good to be exposed to both. Hope you guys enjoyed the video. I know it got a little bit lengthy, but transformations, that's a hefty topic, if you will. Have a wonderful day. America, freedom, rock and roll, Costco, Riverdog Jenny on the gram. See ya.